All right, so yes, I am Dick Lake. Little bit about me. I have been at Microsoft now about 10 years. It'll be 10 this summer. Uh, and I have been fortunate to work on both the InfoSec side of the house and the application security side of the house, and doing that both from an internal perspective, like looking into Microsoft's Wheaties, uh, and then also customer facing. In a previous life, I've done red team stuff. I've done a little bit of the blue team things. But the TLDR is I have seen a lot of stuff. And I think a lot of the professionals will on this group will agree that yes, there are raw vulnerabilities, i.e., things that have a CVE number assigned to them, but probably more frequently it's a series of misconfigurations and often simple misconfigurations. That's the straw that breaks the camel's back. And so, what I want everyone to walk away from this is the importance of having a cloud native application protection platform uh, and how Microsoft Defender for Cloud fills that role. So, probably to no one's surprise, cloud adoption continues to stay in the fast lane. Business leaders want to harness the power of the cloud. They want to use these AI services. They want to use things like containers and functions and Lambda uh, so that they can free up their developers, let them run wild and do what it is they need to do so that they can, make a profit. And one of the Gartner studies found that, about 95% of all of the new initiatives in 2025 are going to be cloud native. So that means they live in the cloud, they were born in the cloud, they use these services like Azure OpenAI or AWS Bedrock or GCP Vertex, containers, functions, you name it. You know, But as this cloud transformation accelerates, it's accelerating innovation and business agility. Attackers also get to capitalize on this. That new environment you deployed, how can I, as an attacker, leverage that? Does that grant me some new permissions? Does it give me a new place to establish little persistence hooks? Those source code repos that you love and cherish. You know, what if I could control those and manipulate the build pipelines, or change how artifact signing was done, or steal your signing key right out of it? Those high-speed AI services. Man, it'd be a shame if somebody were to tamper with all that grounding data that you've been saving up. And so the key thing here, this is slightly awkward build slide, but uh, there's an infinite number of entry points for cyber attacks. Attackers are relentless. They're going to look for the path of least resistance. I would say about 10 years ago when we started off, everyone was very familiar. Somebody's account gets compromised. They downloaded something, or sorry, they downloaded an email. It had a macro enabled Excel sheet. Their account gets compromised. The attacker elevated privileges. They install something like Mimikatz, and then they just start crab walking all through your environment. That can still happen today. There's, you know, that is still a real threat. But now the attacker can also pivot into the cloud workloads, or they can just launch their attacks at the cloud workloads and then pivot down and around from that way. And so the question is, do you really know what's going on in your environments? So, as an example, who can access your data? Like, are your Gen AI apps, leaking sensitive data out to users? And I want you to ask yourself this honestly. Like, can you answer these questions for just your on-prem environment? Now throw in one cloud service provider, then add all of them. And the point is I've tried to do the math to count up all of the possible unique security configurations that exist across AWS, GCP, Azure, and just for compute workloads, and specifically just for Windows Server compute workloads. And the number is large. Uh, Now extend that to Linux, extend that to other cloud workload types, and the problem just gets exponential. And it's probably impossible, if not highly unlikely, that you're going to be able to find an individual who knows, you know, the nitty-gritty details of Azure, Azure Compute and Azure Compute, AWS Compute, GCP Compute, and then also knows Lambdas and all of these other fun little things so that they can do security for you. If you found that person, never let them go. They are a unicorn. So to kind of combat that and uh, to address those security challenges, organizations need a comprehensive approach, and we argue that would be a cloud native application protection platform. So first, what is a CNAPP? And I'm going to just start saying CNAPP because it's easier than spelling it out. Uh, CNAPP was a term first coined by Gartner in about 2021, and it describes an all-in-one platform that unifies security and compliance, and yeah, compliance capabilities to prevent and detect and respond to cloud security threats. And one of the main goals of a CNAPP is to embed security into your processes and ideally at the earliest stage possible so that it becomes less costly to fix these things. All right, build that out real quick. Just going to use a little laser pointer here. So Microsoft provides this comprehensive code to runtime security. And so we start with the secure development aspect of it. We have native security controls that are infused into existing developer workflows that'll help developers uh, code more securely, more effectively. And then that thing gets brought into our runtime environment. And that's where we add in this layer of contextual posture management so we can help you prioritize and reduce your risks across all of your different cloud environments. And then there's the workload protection aspect. Being on the internet is the world's greatest pen test that will ever be provided to you free of charge. You will be attacked, and the question is how do you respond to these events? And so imagine you were a security consultant doing a big picture security assessment of an application, or you were a new hire to a security team for a company. The first thing you the first thing to do is to really get a picture of what's going on. So if I were to break down and assess an application, I'd probably do it using these four layers because each one of these is a domain that a subject matter expert could probably spend hours talking about. So real simply, at the application code level, do we scan for secrets in our source code? What do we do when we find it? Do we just, ignore it? Hopefully not. Do we try and nullify that secret, remediate it out, delete the Git history, all that fun stuff? We then go to DevOps. Are we following the best practices for our given source code management system? Has it been configured correctly? Do we have simple little things like branch protection enabled? On into infrastructure. What happens if an attacker compromises this specific resource or this account? What can they do? Where can they go? What level of access do they have? And then that runtime. If something bad were to happen, would you even know? Like, do you have the signals, all the signals and telemetry that your IR team may want or need? And then, what were the bad things that happened? So let's talk about reducing risk, because that's the main focus here. So in my mind, you cannot convince me otherwise. Security starts with visibility. You cannot effectively defend something if you don't know it exists. If I were to blindfold you, stick you in a room and told you, hey, people are going to come and try and steal your stuff. Don't let that happen. Uh, I set you up for failure. You don't know how big the room is. You don't know what you're protecting. You don't know where the thing is you're supposed to protect, what the entry points are. And since we're talking technology stuff, that item that you're trying to protect may actually be the entry point itself. And so, in case my analogy isn't clear enough, I don't just mean visibility into one of those previous four layers that I showed. Uh, we want all of them. So when we talk runtime, what alerts do we have? Infrastructure, what resources are out there? CI/CD pipelines, how was this built? Who helped build this? Application security, what open source packages are we using? Are any of them vulnerable? And it's my firm belief, posture management is the eat your vegetables of cloud security. It is by no means it is by no means fun. It is not high speed as incident response can be. Uh, but if you want to be healthy, you have to do it. If you want to go on vacation and not get your cell phone blown up because somebody did something naughty in your environment, posture management is your best and first line of defense against that. So let's say you have a picture of what it is you're protecting. Then the next question often becomes how, which is essentially boils down into, to agent or not to agent. Uh, Agentless is great. I don't have to deploy something. The provider will handle that for me. I don't get to see the performance impact because you took a snapshot of the disk and I don't use that anyway. I don't have to manage it. It's great. But agent-based is also great. I get that in-depth visibility. Uh, and that agent-based system is usually tied to an endpoint detection and response tooling so that, I can do things like attack disruption. So there are trade-offs in just choosing one or the other. So what we strive to do is offer customers the ability to do both. That combination of both agent-based and agentless allows you to create this flexible and robust cloud security strategy that really helps you on the scalability and adaptability or adoptability of the tools you're using. The next important thing, and this is kind of a little product history of Defender for Cloud. Uh, I had previously defined what a CNAPP solution is, but I am a very simple man, and I like to break things down. So at its core, we do two things. We tell you when you've done something wrong, and we tell you when someone has done something bad to you. So let's focus on that tell you when you've done something wrong piece. Because we do that, we as a product, we actively measure and evaluate ourselves on how often we're raising an issue and how often that issue then gets resolved. And we look for these trends and trends in the data. Uh, and we've seen it, we've seen the remediation numbers and, how long the average time to remediate is for some of our recommendations, and it can be long. And our job as a product manager is to go and find out that ground truth why. So believe me when I say recommendation fatigue is a very real thing. A large org can have hundreds, if not thousands, of things that should be fixed, but not everything can be a priority. So we've revamped how we do posture management and take things into consideration like how critical is this resource? How exploitable is it? Does it contain sensitive data? How can an attacker go beyond this? And so now when you go to the portal, yes, we are still going to show you things that you need to fix, but it has this layer of contextualization and prioritization applied on top of it so that you can go to the person responsible for the issue and say, we think you should fix this because blank. I need you to fix this because this server is internet exposed. It contains sensitive data. Let's say it's an SSH key, and that SSH key then can allow you to get into my AWS EC2 VM, and that has a connection to a database with sensitive data. So you can build this compelling story uh, that addresses the so what or why should I care? Why should I do this? And so what that really, I'm just going to build this out. So what that really means is behind the scenes, we built the graph. Uh, and then incorporated it into the bigger, Microsoft security graph. And that's great because cloud security does not exist in its own little bubble. It's dependent on things like identity and the devices that we're using or that we use to access or to maintain things. It relies on the build systems and so on and so on. So I can't give my boss or my board of directors an accurate security report unless I'm taking everything into account. It truly needs to be holistic. Ah, that was one more. And so for security analysts, rapid investigation of these things, or security admins even, rapid investigation and remediation is, top of mind. And to streamline their workflows, like lots of Microsoft security products, we're starting to integrate in with Security Copilot to help increase our velocity in helping remediate these things. So you can get things like recommendation summaries. You can delegate it out to a person, or you can get it remediated, and you can remediate it from, say, remediation can come in multiple forms. It can be a script, it can be a set of actions that you have to take. Uh, it could be a recommend, or it could be a pull request that goes into your dev systems to, flip around the setting for an infrastructure as code file. Okay. So before we go into the shift left aspect, I want to shamelessly plug my coworker's Laura's presentation later today. She's going to talk about our integration with indoor labs and showed the importance of doing a reachability assessment. If that's not a term you've heard before, then you really should attend her session. So for large scale organizations, infrastructure as code can be a way of life. It gives you versioning, templated deployments, and all sorts of other little goodies. Uh, for some orgs, I have seen it where no one in the environment has write permissions, and everything must be done via infrastructure as code in order to make it into production. And oftentimes, that's where the misconfigurations start. A very well-intentioned developer finds a bicep or Terraform template to deploy a resource. They incorporate it into their build systems and they deploy it. Uh, but they didn't know that the default setting was X, and in order to be the most secure, it should be Y. And so we leverage a variety of tools like Checkov, IAC, File Scanner, Template Analyzer, Trivy, and Terrascan uh, to run against all of these infrastructures code findings and help bubble up, hey, you said this storage account should be exposed to the internet. Yeah, that's not the greatest idea. Do you really want to do that? And you can do this cloud mapping, from your infrastructure's code template all the way to your runtime resources. And so when we see a fix and we, come up with a remediation thing, we want you to fix it as far left as possible. If you just fix it in runtime, you're going to be playing whack-a-mole because that template will get run again, and you're going to have to fix that same issue. So if we can, you know, shift it as far left, fix it once for all future instances, I'm going to choose that as my option. And then secrets. Secrets in code are just, it's age old. It will be continuous from the end, from now till the end of time. Leak secrets like passwords, certificates, API keys uh, have been, a gold mine for attackers. They will mine your projects on GitHub to see if they can find these. And often these secrets are leaked by accident. You know, people didn't know. I didn't intend this project to get public. I didn't think this was a big deal. And it's usually just a little stepping stone that an attacker can use. And so with GitHub Advanced Security or GitHub Advanced Security for Azure DevOps, you can use secret scanning or push protection to detect and prevent against secret leaks. So, there's push protection, so secrets just can't get into the source code. And let's say you didn't elect to do secret push protection, there's just secret detection. So if we find it, we're going to let you know. Uh, Give you the set of remediation steps that we recommend that you take. Yeah. So in addition to secret scanning, we talk about application security. So code scanning, it is native to your GitHub and your ADO or your source code management systems, let's just say. Uh, which means developers are going to be more productive and more likely to engage and actually fix vulnerabilities. In fact, GitHub Advanced Security shows it's about 7 times faster versus other tools in like fixing long-term issues. Uh, Adding to this is the recent release of auto remediation or auto fix on GitHub Advanced Security. That's estimated for second half of 2025 for ADO. That audio remediation leverages AI to notify developers of vulnerabilities as they code, and also give them the suggestions to fix it. So, okay, you're writing, let's say a Python application, doesn't really matter, but you connect to some form of SQL database. Sure, you can use a raw SQL statement and build your query string as a string variable. Uh, but that's really bad practice. Like you should be using parameterized queries because that nerfs a broad category of SQL injections. And it'll help guide the developer on how to do this. And then there's also that supply chain security aspect. Um, I don't think there are many applications that are written without the use of open source components. Uh, But the fact of the matter is not all open source components are created or more importantly, maintained equally. You will have some developers that maintain their things, they push packages and updates, and you will have some open source packages that, were developed 10 years ago by some random person and they haven't touched or looked at it in years. But it has a ton of vulnerabilities. So which one would you prefer to use? And kind of the last point I'll have on, or one of the last points I'll have on the application and DevOps side of the house. Uh, Too often, we are still seeing developers build something and very unceremoniously tossing it over to an ops team to deal with. And the painful part is developers know that there are issues, like they're using an older version of a package uh, that contains a vulnerability, but they just didn't have the cycles to test the new version, make sure everything is compatible before they went to production. Uh, their tooling already tells them things like this when they build it. And what I'm not advocating for, let's be very specific or very clear, that developers use some new tool. Uh, or on the flip side, the classic infrastructure security folks get unfettered access to source code that we then somehow expect them to know and read. What we want uh, is to bring that same level of insight that the dev team has, that the infrastructure team has, into one place so that we can, work in partnership with our devs to help burn down these issues. All right. So this is just a quick example of like an attack path that would, kind of common that we see. So we often see public repos that have some repository. It could be an open source or it could just be a public one. That gets brought into, say, an image that I'm using. Now I have a vulnerable container image. And I put that, the icon on this case is the server, but let's continue with the container analogy. It's running on a cluster, the Kubernetes cluster somewhere. But it's over permissive. Like that Kubernetes container pod can just go out and touch a bunch of different things, sometimes for valid reasons. Um, but then it gets you to your database. It gets you to more storage things. You can now do malware and start to take access of these things. So when we layer this on, like, how do we look at this as far left? We have the infrastructure as code component. Then we come into the runtime posture management. Are things configured in the most secure manner possible to us? And then our cloud workload protections. In this case, we're talking about malware scanning for storage accounts. So let me just time check myself. All right. This is last little portion of my sections. Today's presentation has mostly been about risks and misconfigurations and how we identify those. But I have to briefly hit on the workload protection aspect of things. Uh, if you are going to have resources on the internet, they will be attacked. So when you do get attacked, it's important that you're able to rapidly contain, eradicate, and recover. Uh, And with all of the various resources that you have, be it computes, APIs, Azure OpenAI, or AI services, this can be, and whether they reside in, say, AWS, GCP, Azure, on premises. Uh, this can be a really big challenge. And so Defender for Cloud tries to offer a robust solution to provide essential features like detection-specific insights that help you identify vulnerabilities before they can really be exploited. And this automatic protection of new workloads ensures that as we scale up or scale out, however you want to call it, our security measures keep pace without manual intervention. Then, once an alert happens or once an incident happens, this gets pumped into, an XDR platform that allows you to do this really rich level of investigation, pivoting from your cloud lens to your identity lens to your on-prem, device lens. And so it's probably one of uh, the worst kept secrets. Microsoft Defender is slowly moving more and more things into our XDR portal. It started off first with alerts, and now we have attack paths that are moving in there to help you build this picture. And so as this cloud adoption continues to soar, um, we're seeing more of those lines blurred, which kind of amplifies the reason for us doing this. Uh, One of the things that our incident response team kind of looked at was about 95% of all of their engagements started because of a misconfiguration, and that's not just a cloud misconfiguration. I mean, misconfiguration anywhere, be it on a server, domain controller, your M365 portal, etc. And that just kind of highlights the siloed approach that we have between, oh, this is my area of security, this is your lane of security. And so by integrating these all together, we can help break down those silos and see the patterns and identify any blind spots that we may have previously had. Okay, then on to the workload plans. There are many. I will not go through them line by line. You can take a screenshot of the photo and see, what resources do we currently have threat protection services for today? Uh, this table is a constantly evolving and adapting thing. Our newest addition onto this is the Azure AI workloads. We hope to go there for as well as Bedrock and GCP Vertex, but we got to start someplace. We're going to start with Azure OpenAI. And that is everything I had. 30 minutes, start to finish. Great. Got some links for you in case you want to do some reading, read up on our documentations, see our notes from the field series. And now we'll turn to thank yous and questions. So I do want to thank my coworker who's been in the chat. I hope you all have been pestering him unrelentlessly. And thank you to SANS for having me.
You're very welcome. That was so interesting, and it's brilliant to see how far Microsoft are investing in this as a process. We've got a number of questions for you as well. So I'm going to start with one though that was posted before the event. Why should I use a Cloud Security Explorer?
So let me quickly switch what I'm sharing here just to give like an example and kind of paint a little picture. Okay. So for anybody who's unaware, this is what Defender for Cloud looks like when you just click into it for, let's say
We
it's,
haven't we haven't got that up on the screen just at the
oh,
moment.
all right. Let me reshare my screen. Boop. How about now?
Perfect.
All
Yeah, we
right.
can see.
All right. So when you come to Defender for Cloud, you get the overview page. Let's kind of do a little history lesson and then like we'll move over to the Cloud Security Explorer and all that fun stuff. So it used to be this was how we would tell customers to, triage recommendations. And they'd get a nice little list here of all of the things that they can do broken into little control groups. And so let's just pick on, say, remediate vulnerabilities and machines should have vulnerability findings resolved. Okay, well, if I'm looking at a specific machine, I gotta pop in here. Okay, let's say this is my newest baby that I just created. Like, it's got two. That was a lot of clicks, if I'm being honest. I think it was like 5 or 6 just to get down to what vulnerabilities are on this one server. Um, Not ideal because you're going to probably have thousands of servers. And there's no contextualization here. Like, yeah, there's two high findings on it, but what do we know about this machine? Uh, and that then comes into the attack path analysis to help build that picture. And so you can see like why why is this thing important? Why is, like let's pick on Park City Jump here. Like we know it's an internet exposed virtual machine. It has high severity vulnerabilities on it. It has a managed identity that then has permissions to a storage account. And oh, by the way, that storage account contains sensitive data. So if an attacker were to compromise this, they could then get to there. And so now you start to have more ammunition on, you know, why should I care? Like, why should I take action? And let's say you burn through all of your attack paths. Then comes Cloud Security Explorer. They're operating off of the same graph behind the scenes. Attack paths are just what Microsoft wants you to know, but we don't have all of the information about your environment. Like, we don't know your business logic. Like, okay, resources over here are, the ones I care about, but I don't really care about those things. Like, help me focus these things down. And so, like, let's find a juicy one. Not tagged as production. Eh, no, log shell. No, we don't have any S3s. All right, I'm now just going to pick a random one. Container images running. Okay, yeah. Let's run this. So we can take this query, run it. I have no idea if this is actually going to return results. I don't know if we set the environment up such that it would. But now we're looking for container images pushed by code repos that have high severity vulnerabilities on it that's used to create a container that's being run by a Kubernetes workload. And we can start to add on to this, just by adding conditions and checks so that I can proactively kind of hunt through my own environment. Does that answer the question?
That really does answer the question. That's yeah. I will say this is a fantastic feature, and I've been putting this into practice, particularly in one of our organisations where we have numerous iterations of a particular environment set that can vary in age, and so it's really useful to get a good overall picture and have that ability to search fast through those processes. So that's brilliant. That's really good. Thank you so much for that demonstration. One of the questions that we get coming up quite a lot, actually, in our Q&A is under which licensing do some of these features come in? In particular, things like the secret scanning um,
Mhm.
and and the cloud search capabilities.
Yeah. Yeah. So let me just crack this open and we can look at things. So, boop, 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 boop. All right, by far the easiest way to enable any Defender plan, straight in the GUI. You can, toggle something on, off, or, tinker with it to your heart's content. Let's just set that there. When we talk posture management, remember, we do posture management, we do cloud workload protection. So let's talk posture management. Right now, we have two tiers. We have the foundational CSPM, which is free. We do not charge $1 for it. And that will look at a lot of control plane things. Are my storage accounts configured in the right manner? Great. That contextualization comes in with the Defender CSPM plan. And so you can see when we say, like, how do I get agentless scanning for my machines? Well, in this case, we can actually get it from Defender CSPM. We can get it from or Defender for Servers P2. There's a couple different avenues that you can get that capability. When we talk about Kubernetes API access, same thing. You can also get this from Defender for Containers and Defender CSPM. But then when we start talking very specific, just in Defender CSPM things right now, API security posture management, permissions management, and our AI posture management capabilities. They all come with Defender CSPM. Then the workload plans, kind of straightforward. Defender for servers, Defender for app service. You can toggle them. They will get enabled. They'll scale with your environment. And I like them. Pretty straightforward.
Perfect. Thank you very much. I mean, you have an awful lot of questions in the Slack channel, so I imagine you're going to be fairly busy for the next 6 hours or so,
Okay.
Answering all of these ones that have come in. So I'm going to just pick one last one while we roll up to our changeover to our next speaker. There's one other one that's come up as well. There's actually one that I find particularly interesting as well, which is do you think that the role of cyber intelligence and digital investigations in current cybersecurity should be increased? And this is from the perspective of both offense and defense.
Yeah. Meh. So this is my personal opinion. Cyber threat intelligence is great for large, mature organizations. If I can tell you in advance, hey, you are about to be punched in the face. If you are not, skilled enough to know what to do with that information, it's probably not going to be that beneficial for you. But if you do know how to consume that, then it will provide value. You can do things. So taking that analogy into kind of the computer security space, hey, this nation state is planning on doing something naughty to your environment because you crossed paths with them, they didn't like you, they sanctioned you, etc. They may launch a cyber attack. If you don't have the ability to rapidly change your environment and harden your environment to their typical TTPs, it's good to know it's coming, but the punch is still going to land. So I like it, but you need to be mature enough to ride that ride.
I do appreciate the integration of the MITRE ATT&CK framework into Microsoft Defender, which includes your adversaries and the tactics that they've got. I think it's a brilliant move, is that?
Yeah, and I mean, I also liken that because Defender for Cloud is not just used by very seasoned security admins and security architects. Like workload protection owners have access to let's say their subscription. Like they can see their report and they can know. So, I could be, let's say, I could be a database guy and really know my stuff about databases and not be much of a security person, but I own these database workloads. They're in the cloud. I've got workload protections turned on them, but I don't really understand all of the threats against the database. Like I write my select star whatever statements. And it helps me understand, what's going on.